SpaceX and NASA have joined hands on multiple missions now. SpaceX has been NASA's reliable private partner for years now, from working together on a modified version of the Starship that will be used for lunar landings in the Artemis program to satellite launches. SpaceX has always delivered. But this upcoming collaboration between SpaceX and NASA sounds like something out of a science fiction movie. NASA is teaming up with SpaceX to launch their Double Asteroid Redirection Test mission, or DART for short. The mission will take off on the 23rd of November from Vandenberg Space Force Base in California on board SpaceX's Falcon 9 rocket. Let's take a look at NASA and SpaceX's insane new plan to redirect asteroids by crashing spacecraft into it. The DART program. The DART program is a multinational space mission being led by NASA to test new methods of planetary defense against objects that are on a trajectory to crash into Earth. The purpose is to be prepared in case such a defense deployment is needed in the future. And honestly, I'm glad someone is thinking about this. There are many disaster movies where everyone dies because we're not ready for an extinction-level asteroid collision. DART aims to prepare us for that eventuality. DART's primary purpose is to determine how exactly an asteroid behaves when impacted by a high-velocity spacecraft. Scientists estimate 25,000 large asteroids are in the solar system. Therefore, scientists think it is imperative to develop an effective plan if a near-Earth object threatens Earth. While in movies, we like to blow up asteroids, in real life that can do more harm than good. The reality is that bombing most asteroids and comets large enough to threaten the surface of the Earth would add uncertainty more than it would mitigate the threat. So instead of one giant rock coming towards the Earth, you will have thousands of smaller rocks coming towards us like a shotgun blast. Very little is known about the physical characteristics of asteroids. In fact, most experts agree that the best route to redirection is a combination of early detection and a low-energy impact. A small change in direction millions of miles away could easily prevent a collision. The plan is to deliberately crash a space probe into an asteroid to test whether the kinetic effect of a spacecraft impact could successfully deflect an asteroid on a collision course with Earth. The DART program is a joint project between NASA and the Johns Hopkins Applied Physics Laboratory. Other labs like the Jet Propulsion Laboratory, Goddard Space Flight Center, Johnson Space Center, Glenn Research Center, and Langley Research Center will be providing support for the mission as well. SpaceX will be providing the launch services for the DART program. SpaceX plans to use its Falcon 9 rocket to deliver the payload. And even though the United States is leading the project, it is not the only country that was interested in the project. International partners such as the space agencies of Europe, Italy, and Japan are contributing to related or subsequent projects. DART stands for Double Asteroid Redirection Test. As the name suggests, this probe will be impacting the asteroid head-on. DART will host no scientific payload other than a sun sensor, a star tracker, and a 20cm aperture camera. The camera is called Dynamos Reconnaissance and Asteroid Camera for Optical Navigation, or DRACO for short. Named after the asteroid that is planned to be hit with the probe. More on that later in this video. DRACO will support autonomous navigation to impact the small asteroid's moon at its center. According to estimates by NASA, the impact force generated from the 500-kilogram DART at 6.6 kilometers a second will produce a velocity change on the order of 0.4 millimeters a second. This will lead to a slight change in the trajectory of the asteroid system, but over time, it leads to a large shift of path, and this path shift should be enough to deflect the asteroid in another direction. DART is expected to alter the speed of asteroid orbit by about 0.4 millimeters a second, resulting in an orbital period change of around 10 minutes. This may not seem like a lot on the surface, but if you look at it over a span of millions of kilometers, the cumulative trajectory change would turn a head-on, perfectly inelastic collision with a genuinely Earth-bound asteroid or comet into a safe outcome. Such a small change in direction so far away can be the difference between something hitting Earth and something missing it. The actual velocity change in orbital shift will be measured a few years later by a small spacecraft called Hera that would do a detailed reconnaissance and assessment. Project Hera was approved in November 2019. European Space Agency will be taking the lead on Project Hera. DART specifications. Let us look at the specifications for the DART spacecraft. It will be using NASA's NEXT ion thrusters for propulsion in space. NEXT stands for NASA Evolutionary Xenon Thruster, which uses solar electric propulsion to provide thrust for lightweight spacecraft. Solar electric propulsion engines have a significantly higher specific impulse than normal chemical rockets, thus requiring less propellant mass to be launched with the spacecraft. So, it makes it perfect for a small spacecraft like DART. DART will be powered using 22-meter squared solar arrays to generate about 3.5 kilowatts of power. This power will then be used by the NEXT-C engine. The C here stands for a commercial variant of the Next Ion thruster engine. DART uses a rollout solar array design. This new type of solar array design gives much more energy than traditional solar arrays at much lesser mass. Traditional solar panels used to power satellites are bulky, with heavy panels folded together using mechanical hinges. Rollout solar array design was tested on the International Space Station in June 2017 as part of the Expedition 52 mission. The DART mission will cost about $250 million, the cost of launch services that SpaceX will be providing. The secondary spacecraft. DART won't be launching alone. In fact, another secondary aircraft will be piggybacking with DART. This spacecraft is called the Light Italian CubeSat for imaging of asteroids, or Lycia Cube for short. This spacecraft is by the Italian Space Agency, the ASI. The Lycia Cube is a small 6-unit cube satellite that will piggyback with DART and will separate shortly before impact to acquire images of the impact and ejecta as it drifts past the asteroid. Lycia Cube will communicate directly with Earth, sending back images of the ejecta after the Didymos B flyby. Lycia Cube will be the external eyes for the mission. We've already mentioned the Hera spacecraft project that will launch towards the Didymos asteroid in 2024 and arrive at the asteroid by 2027 to do a detailed reconnaissance and assessment of the DART mission. It will see how effective the DART project was. Hera project would carry 2 CubeSats called the Apex and Juventus. Target asteroids for the test. We've gone into great detail about the DART mission itself, so let's take a small peek at the target of the DART mission. The mission objective is 65803 Didymos, a binary asteroid system. In a binary asteroid system, one larger asteroid is being orbited by the smaller one. The primary asteroid, called the Didymos, measures around 780 meters in diameter. That is about 2,560 feet in the imperial system. The smaller asteroid is the Didymos B, and it measures about 160 meters or 520 feet in diameter. Didymos B is in orbit around Didymos A, about 1 kilometer away. DART will target the smaller asteroid, Didymos B. For those of you who are wondering if this test is dangerous or not, don't worry. Didymos is not an Earth-crossing asteroid, and there is no possibility that the deflection experiment could create an impact hazard for the Earth. Multinational background of the DART program. Initially, NASA and ESA had separate and independent programs for similar test missions to experiment with different asteroid deflection strategies. But in 2015, NASA and ESA struck a deal under a new collaborative project called Asteroid Impact and Deflection Assessment, or AIDA. Even though parts of the program were later scrubbed because in 2016, Germany said they won't be able to fund their Asteroid Impact mission, or AIM mission, that was supposed to go to Didymos before DART for assessment, AIM would have studied the asteroid's strength, surface physical properties, and internal structure, as well as measured the effects on the asteroid moon's orbit around the larger asteroid. ESA still plans to contribute with Hera program spacecraft for after-impact assessment. Launch plans for DART. NASA has confirmed the launch date for the DART mission. DART will be launching at 10:20 p.m. Pacific Standard Time on the 23rd of November 2021. The launch will be on a SpaceX Falcon 9 rocket from the Vandenberg Space Force Base in California, previously U.S. Air Force Base Vandenberg. This historic base has hosted very popular rockets, such as NASA's Delta IV and the Atlas V rockets. NASA will be streaming the launch live as well.